This video really will not be examined. You won't see any of this directly on the exam paper, but what I want to do is, now that you've sort of looked at a chip, understood binary, looked at logic, is kind of pull them all together and go back to maybe the first term or the first theory lessons that we did on the computer architecture and the processor, and in particular the little man computer, and kind of put these into perspective and where they fit in. So in the last video that you saw, when we started off the binary, I was telling you that for an 8-bit computer, really what we've got is an 8-bit chip. Here's an 8-bit chip. We know it's 8-bit because it's got 8 legs, and those 8 legs can represent a binary number depending on whether there's a flow of electricity to them or not. So if there's a flow, it's a 1. If there's no flow, it's turned off, there's a 0. And in that way, we can represent a binary number on a single chip. So how does this sort of relate to RAM, the processor, etc.? We're going to take a look. So let's go back to our little man computer. So I've dragged this up on the screen, take a screenshot. And here we had RAM, this side, this big block of numbers here. And on the top we've got the address 0, 1, 2, 3, 4, so on. Now I've taken the chip from the last slide, and I've sort of rotated a little bit so it's this way inclined, but it's the same chip. It's got 8 legs. So how does this work with the memory and the CPU and everything else? Well, if I shrink this down to being very small, I can now place it on top of one of these memory locations. So there we go. I've put 2 of the small ones in already, at address 0 and address 1. It's just a chip which can hold a binary number. That's all the RAM is, and it's the whole thing. So I could cover the entire RAM with these chips. Now you should be able to know that each one of these now can contain a binary number, but we really need to know how to work out a decimal number so that we can have a reasonable attempt at understanding what's going on. We don't read binary very well. I'll come back to that time and time again. But all of these memory locations is just a single chip with 8 legs and can hold an 8-bit binary number. And we call them registers. And in fact, this would be an 8-bit computer because it's got 8 legs on each chip. But if I'd got a 16-bit computer, the only difference that would be, we'd still have the same image, but we'd have 16 legs. So at 8 on each side. And if I got a 32-bit computer, I'd have a chip with 32 legs with 16 on each side, or maybe 8 legs arranged around all 4 sides. The whole point is that if I want a different size computer, 8, 16, 32, 64-bit, all I'm doing is swapping out these chips for a larger chip with more legs. So that's RAM. But the same thing also goes for the CPU. And over here I've got the CPU on the left hand side in orange. And the program counter is just one chip, which can hold a binary number, an 8-bit binary number. The instruction register is just a chip, which can hold an 8-bit binary number, as is the address register, as is the accumulator. So inside the CPU, all I've got is a lot of these chips, as well as in RAM. And they just hold binary numbers, and in this case 8-bit ones. So here's my image of RAM. Okay, so all of these chips, really, if I was to do a circuit with these chips, it would get rather large. So they've been shrunk down and included on their own little circuit board, and here they are. All of this contains all of these single chips. It's a bit more complicated than that. There's probably lots more. I mean, I've only got 100 here. This has probably got billions. So the circuitry really needs to be shrunk down to fit on there. My processor, again, as you can see, I've only got 4 bits, 4 4 bytes of information, sorry, not bits. I don't need a processor this large to hold 4 bytes. There's a lot more on board the processor, but they all look like this. Again, we're looking at billions and billions of these to actually make up the processor in what it does. But essentially, they're just simple chips holding an 8-bit number. And I've reproduced the diagram from my previous video here, showing you the red and the blue lines which attach to the pins of the chips. And what these red and blue lines are these buses, these grey buses going up and across and up here to the output and down to the input, and from the CPU to memory, and between the arithmetic logic unit and the CPU, which is actually on board the CPU. But all they are is these wires. So these buses are these wires. So this red and blue set of wires here is called a bus. So that's the little man computer, or a computer, kind of expressed in terms of these simple chips. Now, going back to last term, we looked at logic, and this is a full adder. Don't expect you to understand it or know what it does at the moment. We may cover it a little bit, but this is a simple logic gate, and the reason why I put that there is because that really is what is on the arithmetic logic unit, and I put it on the left hand side over the ALU here. And what this will be is not necessarily an 8-bit chip, but it will be a chip which will look like this. It will have a lid on it, but if I lifted the lid, I would see an adder, and I'd probably see a lot of these adders. On an 8-bit computer, I'd expect to see at least 8 of these on one chip, which would be part of the ALU. So we're linking back now to logic from last term, and linking that logic back to the computer architecture and memory and the CPU, and how it all fits together. So that's my sort of explanation, or my attempt to put some context on what you're learning. You don't need to remember all of what I've just told you. Obviously the words are important. There will be questions in the exam on the words, but you won't see any of this. It won't ask you about these single chips and whether they're part of the instruction register. You won't see a full adder on your exam paper. None of that will appear. But this is sort of put in context, hopefully, around what's happening with the computer. If you're insane and a total geek, and I know that some people, they want the full story, this chap here, Ben Eater, has done a great deal, or a lot of videos on how to build an 8-bit computer on something called breadboards. Now, they use chips that you stick in holes and join together with wires, and you can put LEDs, that's little lights on, etc, etc, using only simple logic gates, and he's documented the entire project. I do not recommend that you watch any of his videos or go there, but if you're the kind of person who thinks that's really geeky, it's something you want to do, even I've never done this, I would love to, but I think I'd need about 2 years to sit down and actually look at it all. But it does put into sort of context everything we've learned and what we've seen on the videos. But this is for real. My versions are at the moment a kind of model. There's lots of flaws. It wouldn't work as it's laid out. In reality, it's just a model showing you how it should work. This will show you how it actually works, going through logic diagrams to chips to all sorts of things, memory. If you are interested, go and have a look at one of the videos, and if you're really interested, show me the model you make.